Methods of Environmental Evaluation by Ambitos Andinos, December 2015. The process of an environmental impact assessment or risk assessment can be visualized in a flowchart that starts with the preparation of the environmental baseline and simultaneously the project definition. This is followed by a screening process to identify environmental aspects of the project, leading to the identification of potential impacts and risks, followed by the incorporation of mitigation proposals, leading to an assessment of residual impacts and risks. This presentation is focused on the screening, identification, and estimation of impacts and risks. The presentation summarizes 5 ways that impacts and risks can be assessed, either qualitatively or quantitatively. Cartographic overlay. Cartographic overlay generates a series of maps with areas of influence by environmental component. Thematic baseline maps for each component should be comparable with one another, reflecting the natural relations between components. Then, the overlay of the project layout with the thematic baseline maps gives the user guides in identification of potential impacts and risks. Impact and risk matrices. Impact matrices start with a list of the project activities and installations on one axis. Environmental aspects are placed on the other axis. These aspects are grouped by the environmental components that are principally affected by them. Each activity or installation has at least one aspect that can give rise to an impact or risk. The matrix can be completed with all the potential impacts and all the risks. All the impacts and risks should then be evaluated either qualitatively or quantitatively. Weighting of impacts and risks. Qualitative ranking or impacts and risks can be carried out using an algorithm based on various factors that influence the magnitude of the impact or risk. One such algorithm is shown here and is known as Piedra for probability, intensity, extension, duration, reversibility algorithm. The significance of a given impact or risk can be qualitatively assessed by combining its magnitude with the value of the affected component. This is known in English as the VEC, or valued environmental component. The significance can be rated between 0 and 100, from negligible to extreme. If the impacts and risks from the matrices are assessed for significance, the more significant impacts and risks can be highlighted as shown in the matrices, enabling many insignificant effects to be screened out of the evaluation. Then a more rigorous quantitative evaluation can be carried out on the significant impacts and risks. Analysis of cause and effect, or chain of effects. One of these more rigorous evaluation methods considers the chain of cause and effect. This considers that any impact or risk follows a chain of cause and effect from the source to the receiving body. An example of this is the effect of aquifer drawdown on wetlands. Wetlands are supported indirectly by underground aquifers that feed surface flows that in turn affect the vegetation and wetland wildlife. The characteristics of the wetland depend on the permanence of the surface water supply, and impact on the wetland will be reflected in changes in its characteristics. So the wetlands are supported by surface waters that emerge from subsurface aquifers. Water supply provides soil humidity, which gives vigor to vegetation, which in turn improves habitat quality. This indirectly affects the wildlife which uses the wetlands. The impact evaluation follows the chain of effect in the 4 components: water, soil, vegetation, and wildlife. If a truly quantitative method for impact assessment is required, some methods can be listed generically as follows: area overlays, mass balance, chemical equilibrium, contaminant transport, energy radiation, social models of cause and effect, economic models. Area overlays are adequate for estimating areas of direct impact, for instance in soils, vegetation, and habitat. Mass balance is adequate for estimating impacts of physical emissions such as atmospheric dust and gases and discharges into water bodies. Chemical equilibrium models are adequate for modeling the dissolution and precipitation of chemical species in water. Contaminant transport models are adequate for estimating the dispersion of atmospheric particles, waterborne sediments, or plumes of dissolved chemical species. Energy radiation models are adequate for estimating the propagation of noise or vibration. Models of cause and effect are adequate for estimating the effects of inward migration and demand for social services. Economic models, a supply-demand matrix, can be used to estimate the generation of indirect employment and tax revenue. These quantitative methods should be used with caution, as they have certain limitations. Firstly, they are highly dependent on the model assumptions and inputs. Secondly, they should be often considered as more useful for indicating trends rather than exact magnitudes. They do assist in designing emissions for a given environmental quality in a receiving body. They are also useful for proposing monitoring points at which impacts are expected to occur. However, they should be verified and calibrated as information is acquired, even during the operation of the project. Simon Catchpole at Ambitos Andinos for more on this subject.